the little subheading under fraction is reducing by prime factorizing. And please make sure when it tells you to reduce by prime factorizing that you do that. So here is an example problem. Example, reduce 375 over 1,000. Give you all a chance to write that down before we go into the excitement of this. If you're asked to reduce these big fractions by prime factorizing, your first step, boys and girls, this might be surprising to you, is you need to prime factorize top and bottom. Now, I will tell you, you don't have to reinvent the wheel. So, like, for example, we're going to do a bunch of these problems, and we're already going to prime factorize like 1,000. So the next time you see 1,000, if you have it in your notes, you can just write down the prime factors that you already have there. You don't have to redo it all over again, because some of these take a little bit of time. So let's look at 375. If I'm prime factorizing 375, and I guess it didn't say what manner you use, how would I prime factorize that? If it was me, I would do the division by primes. Why? Because what number do I know goes into this? Jaden? 5. And I know that's a prime number, so I can use that as my prime number, then I can divide this out. And 5 goes into 375, what is that, 35, 25? 5 goes into that 75 times. I can prime factorize, reduce that by dividing it by what again? 5, because it's 5 goes into 75 15 times. What prime number goes into 15? Elijah? 3. That's a prime number, that's what I want. You have to do it by prime number. And 3 goes into 15 5 times, and that's a prime number, so I can kind of stop right there. So my prime factorization of 375, I write this up here, and I would go from least to greatest, is 3 times 5 times 5 times 5. Are you with me? Now the next time you see 375, ladies and gentlemen, feel free just to put 3 times 5 times 5 times 5 down, and everybody's happy. 1,000 is actually easier. I'll do 1,000 by the 3 thing. What two numbers times themselves give me 1,000? Isabel? 100 times 10. Those are both composite numbers, so they can be broken down. 100 is 10 times 10, correct? 10 is 2 times 5. I'll stop with that 2 and that 5 because they're prime numbers. And 10 is 2 times 5, and 10 is 2 times 5. So what do I get left with? 3 2s and 3 5s. And that's what 1,000 is. And again, if you see 1,000 come up again, you don't have to redo all this. If you got it right here, you can have it, got it down here. Now, that was just step 1. That was a short step 1, wasn't it? Step number 2 is this, okay? You can cross off identical factors 1 for 1 that are on top and on bottom. And you're going to want to look at the example on this because I'm not so sure my definition there is going to do it justice. What that means is this, looking at your fraction that's been prime factorized, okay, if you see the same number, the same factor on top as on bottom, you can cross that off as long as it's 1 for 1. In other words, here's a 5 and there's a 5, so I can cross those 2 off. Here's a second 5 and a second 5 there, so I can cross those two off. Here's a third 5 and another 5 there. Okay, that's all that I can cross off. And step 3, if needed, I need to remultiply. Which means this. Okay, really, realistically, when you cross these off, you should put 1s there, but 1s don't change anything, so we don't need to. 3 is left on top, remultiplying 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. This is my reduced fraction for this. And I agree with those of you that say that's really kind of archaic and hard to do or whatever, but it kind of teaches you about what reducing fractions is really all about. So you will do it and enjoy it for the most part. Yeah? Got that? So anytime you see that, that's what they're going to ask you to do. Again, don't reinvent the wheel. If you come up to 1,000, you already got the prime factors. If you're 375, you already got the factors, so you don't need to redo all that. So another example, you ask, how about this? 875 over 1,000. Well, like I said, we already did 1,000, so I'm just going to jot that down. It was 3 2s times 3 5s. How fast that went. 875, I'm going to have to sit down and do that. Again, if it's this thing, I probably would do division by primes, just because this is 37 is 7, 35 and 20, 175. What goes into 175? Another 5, which is 35. What goes into 35? Another 5, which is 7. Anything go into 7? Nope. So I can stop. These are my prime factors of 875. 5 times 5 times 5 times 7. What's going to cross off there? Keith?
All the 5s.
Yeah. 3 5s on top will cross off with 3 5s on bottom. When you remultiply it, you'll end up with a 7 on top. 2 times 2 is 4 times 2 is 8 on the bottom. 7 eighths is the reduced fraction for that. Let's do an easier one. What if you were given 36 over 81? I'll give you a chance to try your hand at that. 36 over 81. If you prime factorize all of that. Prime factorize 36, you are going to get what? Elijah? Prime factorizing 36, you get what? What do you get when you prime factorize 36?
2 times 2 times 3 times
2 times 2 times 3 times 3, which is 6 times 6. Very good. Prime factorizing 81. What gives you 81? Brooklyn?
9 times 3 times 3.
Well, unfortunately, 9 can be broken down into 3 times 3, so you with me? 9's not a prime number, so your 9 would have to be that. Now again, when you see 81, you know it's 4 3s times themselves. 36 is 2 2s and 2 3s times them. Now, what crosses off? Laney?
2 3s on the top.
2 3s on the top with 2 3s on the bottom. Remultiplying it again, you end up with 4 over 9. 4 over 9. If, children, everything crosses off on top, if everything crosses off on top, let's say you had this, 2 times 2 times 3, and on the bottom you had 2 times 2 times 3 times 3, and everything on top crosses off, because the 2's cross off and these 3's, your answer is not 3, okay? You have this fraction line, there's a 3 on the bottom, and I said this before, really when you cross these off, there's supposed to be 1s there. Okay, if everything crosses off on top, you need to keep the 1 on top. Okay, if everything crosses off on the bottom, let's say you had 3 times 3 times 7, and you had 3 times 3 on the bottom, and the 3's cross off, well, you still have a 1 on the bottom, but 7 over 1 is just 7, so you don't need that 1. If everything crosses off on top, you definitely need the 1 because 1/3 is not the same as 3. If everything crosses on the bottom, you don't need the 1 because 7 over 1 is the same as 7. So just make sure you note that. Enjoy that.